Dear children, it is a 5 marks question from the question paper, and this question is from the chapter named Application of Trigonometry. Now let us try to solve the question. That is the question number 38 from the question paper. A spherical balloon of radius r subtends an angle theta at the eye of the observer. If the angle of elevation of its center is alpha, find the heights of the center of the balloon. Find the height of the center of the balloon. Here this is the center of the balloon, and you know that the balloon is shown here. This is the balloon, and OP is the radius of the balloon. OP is the radius. Spherical balloon subtend the angle theta. So this is the angle from this to this. That is the angle theta that is subtended by the balloon. And what you have to find out here, we have to find the height of the balloon, and also it is given there is one more angle theta, that is the angle of the elevation of the center. Angle of the elevation of the center from the point A. Here r value is not given and theta is also not given. So in terms of theta, r and alpha, we have to mention the height of the balloon from the ground. Now here you observe there are two right angle triangles. One is the right angle triangle OAP. This is the right angle triangle. And what is theta here? Theta is theta by 2. From here to here, angle OAP is theta by 2. And one more right angle triangle is there, that is OBA. Right angle triangle OBA. Here you observe the right angle triangle OBA. There theta is angle of elevation is alpha. Alpha is the angle of the triangle OBA, and theta by 2 is the angle of the triangle, right angle triangle OPA. So let us apply the trigonometric ratio to both the triangle. Now you write the names of the first triangle, triangle OPA. So you write the names of the triangle, both the triangle. First you take the triangle OPA. In the right angle triangle OPA, let us write the trigonometric ratio. So you write in the right angle triangle OPA, let us write the symbolic of right angle triangle. Which triangle? OPA. Here the theta is theta by 2. This whole angle is theta. Therefore, for this triangle, the theta we have to consider theta by 2. From here to here, what is that? Theta by 2. Therefore, for that angle which is the opposite side, this OP is the opposite side. OP is the opposite side, and OA becomes the hypotenuse. You know that OA is the side opposite to the right angle. Therefore, OA becomes the opposite side. Why you have to take OA? Because this OA is the common side of both the right angle triangle, OPA and OBA. Therefore, let us consider the side OA only. That is the hypotenuse of the right angle triangle. And you must write the ratio containing the hypotenuse and opposite side, that is the sine theta. So you write sine theta. In the place of theta, let us write theta by 2. Sine theta is equals to what? Opposite side by hypotenuse. Hypotenuse, which is opposite side here, OP. OP by, which is the hypotenuse, OA. So here you got sine theta by 2 is equals to what? OP by OA. OP by OA. Here OA is the common side for both the triangle OPA and OBA. So let us express this in terms of OA only. Then OA becomes OA is equals to OP by this sin theta by 2. Here you exchange the place of OA and sin theta by 2. It becomes OP by sin theta by 2. Sin theta by 2. Consider this is first one. Here we got OA is equals to OP by sin theta by 2. Here we have taken this as first. Now you take the other right angle triangle. Which triangle? OBA. For this also OA is the hypotenuse and here OB is the height of the balloon from the ground. So let us express theta in terms of h only. And for that right angle triangle, here we have to take the angle alpha, angle OAB. And for that alpha, OB becomes the opposite side and OA becomes the hypotenuse. Again, let us use the trigonometric ratio sin theta, that is sin alpha. In the place of theta, we have to take alpha. Then you write sin alpha is equals to again opposite side by hypotenuse. Opposite side by hypotenuse. Then we have to write OB by OA only. So let us take sin alpha is equals to which triangle? In the right angle triangle OBA. Then you write in right angle triangle OBA, again sin alpha is equals to opposite side by hypotenuse. Then you write sin alpha is equals to opposite side for the alpha is, for alpha opposite side is OB and hypotenuse is OA. Let us write that as OB by OA. So you write this is what? OB by OA equals OB by OA. Again let us express this also in terms of OA only, because here we got OA is equals to, then let us get here also OA equals, so exchange this OA and alpha, that is OA equals what? OB by sin alpha. Now let us consider this is second. In first you got OA is equals to OP by sin theta by 2, and here also you got OA is equals to OB by sin alpha. As LHS are same, we have to consider as RHS are equal. Therefore let us write from first and second. From first and second what we have to write? OP by sin theta by 2 equals what? OB by sin alpha. So let us write from first and second. Let us write what? OP by sin theta by 2 equals OB by sin alpha. Here what is OP? OP is radius R. And what is OB? OB is the height. So in the place of OP let us write R, and in the place of OB let us write H. So OP is what? Radius. That is R by sin theta by 2 equals OB is H by sin alpha. Now we have to find out height, that is in terms of R, theta and alpha. So here H equals what? You can exchange this. H by sin alpha is equals to R by sin theta by 2. Then H is equals to what? It becomes R into sin alpha by sin theta by 2. So we write H is equals to what? R into sin alpha by what? Sin theta by 2. This is the relation for H. Here R is not given, that is R is given R only, and alpha value and theta values are not given. So this becomes the final answer for the question.